Okay, good evening. Lesson 11.5, areas of regular polygons. So we're going to go away a little bit from the quadrilaterals to include some other important shapes. Again, sticking to those shapes that are very well defined. Whenever we have an area, whenever we come up with a formula for a figure, the simpler the figure, the easier that formula is to find. So that is very different than this irregular pentagon here. As you can imagine, finding the area of this is quite a bit more complex. There's a lot more at play with an irregular polygon than the regular ones. So we've got a square, it's a regular quad, an equilateral triangle for the triangles there. Here's a pentagon. All right, so it's regular, equiangular, as well as equilateral. So a couple of, I'm going to take some of these figures off, and we are going to talk about a little bit of a few terminology here. The first one is every regular polygon has got a center. Okay, notice that this irregular polygon would have no center. Okay, no nice center. So we've got a nice center for every regular polygon. It's the hub of the wheel if it was a wheel. It also has a radius. The radius goes from the center to the outside point. It really is the radius of the circle that circumscribes the polygon. Okay, so you can see the circles there, and the radius of this triangle, this radius of this equilateral triangle, is also the radius of the circle. The radius of the pentagon is the radius of that circle, and so on and so forth. Now we have an important word. We have mentioned it before. It is called the apothem. Notice the apothem. The big two words here that you need to latch on to here is apothem and radius. So this here is a radius, and this here is the apothem. Now the apothem is always starts from the center, goes to an outside edge perpendicularly. Because it's an equilateral polygon, it will bisect the base that it goes to. Also, we should realize that the radius will always cut this angle, bisect that angle as well. So here is my radius right here. It bisects that angle, and my apothem here is perpendicular, and it bisects the base there. Okay, so looking at the square, here is the, what is that called? The apothem. And this right here is the radius. What does the radius do? It bisects the angle. And what does the apothem bisect? It bisects the side. All right. How about this one? What am I pointing at right there? What am I pointing at? That is the apothem. And what does it bisect? The side. And this here is the radius. And it bisects the angle. What am I pointing at here? What is that of the octagon? It is the radius of the octagon. This right here is the apothem of the octagon. The apothem is perpendicular, and it bisects the side. The radius bisects this interior angle. Okay, so that's terminology. Every regular polygon has got an apothem and also has a radius. Irregular polygons do not. Okay, now our lesson is to find areas of regular polygons. Okay, and I'm going to start by looking at the triangle here. Let's start by looking at the triangle and make some observations. I'm going to hide the circle, don't need that. Orient this a little bit differently. So here's my equilateral triangle. what we should notice is the apothem and the radius, and what do they form? They form a triangle, don't they? In fact, if I pencil in all of the radiuses, we see that the radius actually divides the polygon into nice triangles. Looking at this pentagon right here, you've got 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5 triangles. 5 triangles in a pentagon. Interesting. The radiuses break this hexagon into 1, 2, 3, 4, 5, 6 triangles in the hexagon. Square, 4 triangles in the square. The radius divides the octagon into 8 triangles, and all 8 triangles are congruent. All 6 of the hexagon triangles are congruent. All 5 of the pentagon are congruent. All 3 of the equilateral triangle are congruent. So, we know how to find the area of this triangle. Okay, of the triangle. So let's just look at this one right here. Find the area of that. Using our terminology, if this is my radius, and this is A for apothem, and this length here is my base, right? So in this case, I know that the area of this triangle right here is 1/2 the apothem times the base. And then how many triangles do I have? I've got 3 triangles that create that, right? This one, and this one. So I need to multiply that by 3. Okay? So I'm going to multiply that by 3 to get my total area of this triangle. Okay? Now, if I multiply 3, I'm gonna use the commutative property of multiplication and just write this differently. See if you see that this is the same thing. 1/2 times the apothem times 3 times the base. Notice what I have here. All I did is, since this is multiplication, I'm just multiplying all 4 of these together. I can multiply them in any order. I want to see multiplying the 3b together, because if I take 3 b's, 3 bases, this is a base, it could be a base, right? 3 of them, I have the perimeter. It's 1/2 the apothem times perimeter. So in order to find the area of this equilateral triangle, if I have the apothem and perimeter, I can multiply the apothem times the perimeter and divide that value by 2, and I have the area. So here is your area formula for a regular polygon. Okay, 1/2 apothem times perimeter. Now, you should see that that should always work for any of them. So let's look at the pentagon here. Here I've got the apothem. If I multiply that by the base, so I take the apothem, multiply it by the base, have to divide by 2 because that's a triangle, divide by 2 because that's a triangle, and then that gives me one of these triangles, and I've got 1, 2, 3, 4, 5. Multiply that by 5, that will be the area. That's the area of the pentagon. What is 5 times b? That's my perimeter. So it's really 1/2 the apothem times the perimeter. Okay? Let's take a look at the octagon here. See it in this case. Here's my triangle. Here's my base, which is really the side of the octagon. Here's my base times my apothem. So I take 1/2 the apothem times my base, and that equals this area. And then I've got 8 of them. I've got to multiply this all by 8 to get the area of the octagon. And what is 8 times b but the perimeter? 8 bases is the perimeter. So 1/2 a times p equals the area of the octagon. And we could go on and on and on. So here's the lesson for tonight. The area of a regular polygon is equal to 1/2 times the apothem times the perimeter. Okay? So when you start solving problems, you're going to want to be thinking, how can I find the apothem? How can I find the perimeter? Given the information that I've got, can I find those things? Let's go ahead and try one. Go on to the first example. An equilateral triangle has a side 10 centimeters long. Find the triangle's area. So here's a picture of equilateral triangle. Now let's label it. Each side is 10 units long. So if this is 10 units long, all I need to find now is the apothem, because I know the perimeter. Perimeter is going to be 30. So how do I find the apothem? Now, to find the apothem, you need to think about the shape that you're looking at. How do I find the apothem here? Well, let's look at the triangle. Remember that an equilateral triangle has interior angle measures of 60 degrees. In fact, all of the regular polygons have fixed angle measures. So remember, the radius bisects it, so this is 30 degrees. Remember that the apothem is perpendicular, so this is a 30, 60, 90. And now you see it. You see how to find the apothem. This is going to be 5. Let me use a different color. This is going to be 5. This is going to be 5. This is my long leg. 5 is my long leg. So how do I go from long leg to short leg? 5 root 3 divided by 3 is my short leg. So my apothem is 5 root 3 over 3. And so now I can find my area. Area equals 1/2 the apothem times the perimeter, which is 1/2 5 root 3 over 3 times the perimeter of 30. 10 plus 10 plus 10. And now we can clean that up. Half of 30 is 15, so this is the same thing as 15 times 5 root 3 over 3. And 3 goes into 15 5 times, so that's 5 times 5 root 3. This comes out to be 25 root 3 centimeters squared. Here's my final answer. One point of interest is you should realize that, notice I only gave you one characteristic of the equilateral triangle. I gave you side length. From side length alone, you are able to find the area. That should say something about this shape being simple and being easy to understand. All we need to know is the perimeter or each side length of the equilateral triangle, and we can calculate its area. Let's take a look at another example, a little bit more difficult. A circle with radius 5 centimeters is inscribed in a pentagon. Find the area of the pentagon. So here's my pentagon. Here's my pentagon. I've penciled in my radius, all of my radii, and my apothem. Apothem is there. Let's go ahead and put the circle in there. it is inscribed. So if it's inscribed, that means it's coming down here. It's inside, not outside. That's circumscribed. This is circumscribed. This is inscribed. Okay, so there's my circle. It's inscribed. Well, that was just a fancy way to give you one information. You see that? It was just a fancy way to give you the apothem. Notice this apothem then must be 5 centimeters because that circle there is the radius of that circle. So the circle was only helpful insofar as telling us what the apothem is. Now, if I know the radius is 5 centimeters, how do I find out the area of this polygon? Okay, so the area is going to equal 1/2 times the apothem times the perimeter. Well, so far we're only fortunate enough to have the apothem. That's 5 centimeters. Looks like we need to hunt for the perimeter. Now, just as in the last problem, just like in the last problem, we were able to use the angle measures of the triangle to figure out the sides. And that's what we're going to do now. If this is a pentagon, that means I've got 1, 2, 3, 4, 5 angles. My radius is break this into 5 angles. So what is the angle measure of each one? Take 360 divided by 5. So this angle right here must be 360 degrees because that's all the way around the circle. 360 divided by 5 is 72 degrees. So this is 72 degrees, this one is 72 degrees, this one is 72 degrees. Now it doesn't matter what polygon you have, you can always divide it and find this one. Now, the apothem has cut that one in half, so I'm going to divide that by 2 to get 36. This angle here is 36 degrees. Remember, the apothem is perpendicular. So I've created that's perpendicular, and what do I have now but a right triangle? A right triangle. Okay, so let's think about our right triangle trigonometry. If this is a right triangle, we should be able to find the opposite side. This is the side that I need to find out. So, let's go to our Radar Talk, SOHCAHTOA. Which of these do I want to use? I've got an adjacent and I've got an opposite. So adjacent and opposite is tangent. Okay? So the tangent of 36 degrees is going to equal opposite over adjacent. X over 5. I'm going to call this question mark down here x. Now let's solve this. Multiply by 5 on both sides to get 5 times the tangent of 36 degrees equals x. And then go to your calculator, multiply the tangent of 36 and multiply that by 5. X is approximately 3.63 centimeters. And now I'm home free. If this is approximately 3.63 centimeters, what then must my perimeter be? Well, double that to get this value, right? So I'm going to multiply that by 2 to get approximately 7.26. And then I'm going to multiply that number by 5 to get my perimeter, because this is 7.26. This is 7.26, 7.26, 7.26. So multiply that by 5 and I get 36.33 is the approximate perimeter. Now I can plug in 36.33 into my formula, and I can multiply that by 5, divide by 2, and I get approximately 90.82 centimeters squared is the area of this pentagon. Okay, now that was a little bit more involved. You had to take we're still using the basic formula for area because it's regular. I had to take the radius being 5 centimeters of an inscribed circle and say, hey, that's my apothem, and then I had to use trigonometry to find that missing side so I could find the perimeter. Okay? So you kind of have to be ready to use some trigonometry for these problems. All right. I'm going to clear this and go back to the first one. And just as a review, if it's equilateral triangle, then we know these angles. This is a 30, 60, 90 triangle right here. We just did an example of the pentagon. That was 72 degrees, and you had to use sine, cosine, tangent. If you're dealing with a square, well, we've got so many ways to find the area of a square that's not too much of a challenge. But what is true about these triangles? These triangles are what? 45, 45, 90s. So that easy triangle, right triangle, is going to be used. How about if I've got a hexagon? How does a hexagon look? Well, a hexagon actually is a really nice one. And your homework will use hexagons because it does work out nice. That triangle is nice because 360 divided by 6 is a 60-degree angle. And then if you divide one of these to find your apothem, then you've got a 30, 60, 90 here. So octagon, not so easy again, although some regular polygons are going to come out nice just because of the way their angles do. Others are not so nice, and you'll have to use sine, cosine, and tangent. Okay, so hopefully that's enough to get you started. The whole point here is 1/2 the apothem times the perimeter, and the task really is finding the apothem and finding the perimeter for each of these regular shapes given whatever information they give you. So we'll do some practice with that in class, and with that I will sign off. Good night.